This is topic 15-4, Analyzing Quadratic Functions, Day 1. Our central question today is how can I connect solutions, roots, zeros, and x-intercepts of a quadratic function? And we will be using a calculator in order to do this. So I need you to complete the top half of the Making Connections worksheet number 11. That is our bill work for today. And also you should have out your topics from the previous topics so that we can refer back to them if necessary. Our first two problems that we're doing from the Making the Connections is reminding ourselves how to graph lines. Our first problem, it is in standard notation, and what we need is to get it into slope-intercept form, or y equals mx plus b form. So that means we need to take the equation and actually solve for y. In the end, I want y equals something times x, that'll be my m, plus something, and that'll be my b. So to get y by itself, I'll already notice, hey, the 8 is already on the other side, so it is going to fall into my free-falling space over there. We have now taken care of the 8. Now we need to move the negative 2x to the other side, so we'll do the opposite, that is plus a positive 2x, and I'll show it over here, plus a positive 2x. That means the number in front of the x is a positive 2, so I'll put that in my blank there. Last, we need to get rid of the 4 that is with the y, and so this is 4 times y. That means we're going to divide by 4. I'm going to divide everything by 4. So underneath my 2 is divided by 4, and 8 is divided by 4. When we simplify that equation, we get y equals 2 over 4 is 1/2 times x plus 8 divided by 4 is 2. So from this equation, we get our y-intercept, or b, is equal to 2. And since it's a y-intercept, we write it as 0, 2. And our slope is 1/2. It's a positive slope, means we should have a line that is increasing, which means the top number we're going to go up and the bottom numbers to the right. So let's start at our beginning point. Our beginning point is the y-intercept of 0, 2. On our y-axis, we go to 2. And then we'll use our slope in order to move that point. So from the beginning point, we're going to go up 1 and to the right 2. Up 1 to the right 2. And continue this pattern of up 1 to the right 2 until we go throughout the entire grid. Now to get the other side, we're going to do the opposite, which means we're going to go down 1 and to the left, so that it still follows the pattern, but I can now fill in the entire grid. I have my points, I can connect the dots, and sure enough, it is an increasing line with a positive slope. Our second problem, our equation is x equals -7. If I look back at my first problem, I can say, hey, it had both an x variable and a y variable. That means it should cross my x-axis and my y-axis. In this equation, however, we only have an x variable, and it says my x must be equal to -7. So it can only touch my x-axis. So on the x-axis, we're going to find -7. And the only line that I can draw through that point that touches the x-axis has to be a line that goes up and down, or a vertical line. If my line goes left or right, it will cross the y-axis. So I have to draw up and down because the only variable in that equation is x, so it can only touch the x-axis. Therefore, we have a vertical line. At this time, we're going to check assignment 15.3. And so these are the answers to 15.3. If you need more time, you may pause the video. Okay, so our topic for today, analyzing quadratics. And again, we want to make the connection among solutions, roots, zeros, and x-intercepts. So we're going to learn how to use our calculator to help us out with those kinds of things. We would need a calculator. And you will notice that the right-hand side gives you all the instructions on how you're going to use that calculator. So if you need to, you can make extra notes on the side if there's something that you need extra information on. Our first question is, how do we graph, or how do we use our calculator in order to graph our quadratic? Well, we have a y equals, and our calculator has a y equal. I'm going to clear my calculator because it was being used before, and I want to start new. So calculator has a y equal, my equation has a y equal, there's my y equal. So that means I am going to input my equation into the calculator using the y equals button, and that'll give me a y1. And we're going to type in the equation, x squared plus 4x minus 5. So on your calculator, let's do x squared plus 4x minus 5. Then we press graph. That will give us a picture of our quadratic or our parabola. So what I'd like you to do is to make a little sketch. It doesn't have to be perfect. You're going to draw an x-axis and a y-axis, and you're going to do a little sketch to show me on your notes, hey, this is what it should look like. I've had lots of practice, so mine comes out to be pretty good. Main thing I would look for is to see your vertex has to be to the left of that y-axis, because that's where we see our vertex on the graph. Now we're going to use the calculator to find the vertex. In our previous unit, we had grids and we could count how many spaces or how many lines we went to find the x and the y coordinate. On the calculator, you may not be able to see that well, so we'll let the calculator do it for us. First, let's recognize the vertex is a minimum. It is the lowest point on that parabola. That's going to be very important when we do the calculation. So I said we're going to use the calculator to calculate something. In order to get to where the calculator can calculate something, you're going to press second trace. Anything with a box around it tells you that is a button on the calculator. So we'll hit the second button and then the trace button. If you look above the trace button in blue, you will see calc. We want to get to the calculate screen, and sure enough, calculate comes up. Now, since our vertex is a minimum, we just answered that in part A, we want to calculate the minimum. The minimum is number 3. So C says since the vertex is minimum, press 3. We'll press 3. I can just press the button itself. Now you're going to get a bunch of questions. If I look down here, it says left bound. So D says for the left bound, we're going to use the left arrow key, that's this one here, to move your cursor to the left of the vertex. If I look at my picture, my vertex is down here. I need to be on the left side of that point. So I will continue to hit my left, and I see the cursor moving. I kind of lost it, but now I see it again, and sure enough, I can tell it is to the left of that point. So on my little graph up here, that point is about right here, and I'm going to call that my left bound, or LB. And I'm going to put LB down here so I know what it stands for. Once I am to the left of that, D says after I moved it, press enter. Let's press enter. Now it's asking for the right bound. Well, I need to be on the right side of the vertex. That's the important part, of the vertex. So I'm going to move my cursor until I am to the right of that vertex. I need to be somewhere on the right side of the parabola. So I'm going to keep going until I see it. And sure enough, I see it there. And so I'm going to mark on my graph. I use this point over here to be my right bound. And I'm going to put an RB down here so I know on my little sketch. That's why I chose a point over there. So when I press enter, because it tells me press enter, the last thing it says is for to guess. And if I look, there's a question that says guess, and I just have to press enter. When I press enter, I get that my vertex, or in this case, the minimum point, is a -2, -9. The x-coordinate is -2, the y-coordinate is -9. So what the calculator did is it took that left bound, and it took that right bound, and it found what is the minimum point between those two bounds, and that's why we were able to come up with the vertex itself. That's why it's very important that when you're doing the left bounds and the right bounds that you need to be to the left of the vertex or to the right of the vertex. If you don't get to the left or the right, you will not get the correct answer. So vertex is -2, -9. We're going to use the same equation, and now we're going to, first we're going to solve. Notice this is the same equation, and we're going to solve by factoring. So we did factor in our last unit. In order to factor, we need an S, our sum, and we need our P, our product. Our sum is the 4, so the number in front of the x. Our product is the number in front of the x squared, and our constant, or negative 5, and that gives us negative 5. Now I need to know what two numbers are going to multiply to give me negative 5 and add to give me a positive 4. Those two numbers are 5 and negative 1. If I multiply them, I get my negative 5. If I add them, I get my positive 4. So to factor, we're going to take those numbers and put them in the bottom of our fraction because we're using the bottoms up method. Top number we get from the number in front of the x squared. If there's not a number shown, there's an understood 1, so I put a 1. Now I can see, can I simplify those fractions? We cannot simplify the fractions. They are simplified, so now we will write our factor. We're dealing with x's, so I'll put an x up front. And now using the fraction. The top number tells us the number in front of the x. Bottom number is the number behind the x. That should not be there. So it's a positive 5, so I'm going to put plus 5. My second factor, top number in front of the x, bottom number behind the x, it's a minus 1, so I put, or it's a negative 1, so I put minus 1. This is now equal to 0. So we've taken our quadratic and wrote it in factored form. Now we're going to take each factor and set them equal to 0. So x plus 5 equals to 0, and x minus 1 equal to 0. Notice I'm no longer showing the 1 that's in front of the x, because 1 times x is just x. Now we get to solve for x. We're going to box our variable, draw our line, get rid of the number not in the box. That means we have to subtract 5, because it's the opposite of plus 5. So positive 5 minus 5, that's 0. It's gone. I am left with x over here. 0 minus 5 is a negative 5. So we have one value of x. X is equal to negative 5. Now let's look at our other one. Box my variable. I'm trying to get the x by itself, so get rid of the number not in the box. We'll add 1 to both sides. That leaves us with an x by itself, which is what we want, because 1 minus, or negative 1 plus 1, that's 0, and then 0 plus 1 is a 1. So our two solutions are x equals negative 5 and x equals 1. Now number 4, we're going to use that same equation, and we want to find the x-intercepts. So I'm going to use this graph in order to demonstrate what the x-intercepts are. X-intercepts means it's where it crosses the x-axis. So the 2 points where it crosses the x-axis, these are the 2 points we're going to find. Sometimes it's easy to look at the graph and be able to figure it out, but if your eyes are like mine, it might be a little more difficult, but our calculators can do it for us. What you will notice about those 2 points, because they are x-intercepts, we know that the y-coordinate of those points have to be 0, because they are on the x-axis. So when it says find the x-intercepts, that means y must be equal to 0. So if I look at this equation, I have a y equal. We're saying I want this y to be equal to 0. So now we're looking right at what we have up above. X squared plus 4x minus 5, and the y is equal to 0, so it's equal to 0. I'm going to rewrite my equal to 0 on the right-hand side just because I like it over there. To use the calculator, we already have the x squared plus 4x minus 5. This is in our y1. What we're going to do is put the y value of 0 in our y2. So that is step A. Let's go on back. We go to y equals. Our first equation is already in there. Y2, we're going to let equal to 0. Press enter. Now we're going to do second trace. That's so we can get back to the calculate button. And I said if it was a button on the calculator, it should have a little square, so I'm going to put a little square there. So second trace. I now want to calculate. What I'm going to do is I'm going to calculate where these two lines intersect. Okay. Actually, let me go back. I forgot to talk about graph. We got our two equations in. Let's graph. And what you will notice is that this graph really didn't change. Our first equation is still the y1, or it still gives us our parabola. The second equation, however, the y equals 0, because we have the x-axis, you don't actually see it, but it's where your y value is 0, and then it's a horizontal line that goes through that point. So the y equals 0 is actually on your x-axis. So when we calculate the intersection, we are calculating where does the parabola intersect with this line y equals 0, or our x-axis. So now let's calculate the intersection. Now we know we're calculating an intersection between two lines. So number 5 is our intersection. And then you will need to press enter 2 times. You're pressing enter 2 times when it prompts you for the first curve and the second curve. So I see first curve, there's my 1. Second curve, there's my 2. Now it will ask for a guess. You need to use the arrow keys, either left or right, to move the cursor to the one intercept that you want to find. So the first one we want to find, let's do the one that's on the right. So I'm going to move my cursor to the right, and you will see the cursor is getting closer. I even passed it up. I'm going to get as close as I can, or what I think is on it, and then don't forget to press enter. Once you press enter, you will see intersection 1, 0. So one of our intersections is 1, 0. But now there's 2 of them. It intersects 2 places. So now we want to find the second intersection. So we just found the one that's on the right. We know it's 1, 0. Now we need to find the one that's on the left. We're going to do the same steps from C on. So second, trace, number 5, press enter twice. So first curve, enter, second curve, enter. Now my guess, I've already done the one that's on the right, so I'm going to arrow over and get the one that's on the left. Put it on it as close as I can, press enter. Our second intersection is -5, 0. So we know that the second point is -5. So we have found the intersections using the calculator. The last thing that I asked then is, what do you notice about the x-intercepts found in number 4, which are these 2 intersections that we found, and the solutions that we found in number 3. So if I look at my solutions in number 3, well, I had a solution of x equals -5 and x equals 1, and I look at my x-intercepts and realize, hey, they have those same x values. One is -5, one is a +1. So they are the same. Forgot the word are. They are the same. What this tells us then is that we need to know some vocabulary. Is that there are several different ways that we can ask to get the same information. In number 3, I asked you to solve it, and I said using factoring. Some of you still struggle with factoring, so from now on, if I say solve this quadratic, you should know, hey, I can actually find the x-intercepts, putting in the left-hand side into y1 and the right-hand side into y2, and I can get the 2 x values that are solved for. You may also be asked, find the x-intercepts. And if you're really good at factoring, you can say, well, I'm going to factor this, and when I factor, I know this is the x-coordinate of the x-intercepts. So we have now determined that the x-intercept, and I can't spell, so x-intercepts is the same as when you find a solution when you're asked to solve. But you could also be asked to find the zeros. You could say, find the zeros of this quadratic. That is the same as saying x-intercepts and solutions. And last, you could be asked to find the roots. So if you're asked to find the roots, they're asking, what are the x-intercepts, or what's the solution? So we asked ourselves, how can I make connections among the solutions, the zeros, and the x-intercepts? Well, we know that they all mean the same thing. So I'm also going to write a couple extra things. We did use the calculator to find the vertex. And when we did that, we're either finding a maximum or a minimum, depending on if it's a maximum or minimum vertex. And then we can also use calculator to find the x-intercepts or the solutions or the zeros or the roots, because they are all the same thing. And the way that we did that, we did y1, we put in our equation, and the key here is that y2, we set it equal to 0, and then we calculated the intersection. This concludes topic 15.4.